the inner transition elements. See, we are talking about here the F block elements. See, we know the 28 elements of the F block are placed separately from the main periodic table because their actual position lies inside the D block. As the 4f and the 5f are filled after getting one electron in the 5d and 6d. So we cannot since separate the D block, we have no other choice to place them separately below the main periodic table. The F block consists of two series of 14 elements each. Now the series starts from the first series lanthanum, which actually belongs to your 6th period. This lanthanum is La, its atomic number is 57, and its electronic configuration is, we believe that it will be 4f1 and 5d0 and 6s2, but what we get in place of getting 4f1, 5d0 and 6s2, what we get is 4f0 and 5d1 and 6s2. Since this electron, last electron, 57th electron of the lanthanum enters the 5d, we are forced to place this lanthanum in the D block. But then what we find is from the very next element, cerium 58 to lutetium 71, all of the rest of the 14 elements which comes after lanthanum, they all are having their electrons entering the 4f. The configuration of cerium 58 is 4f1, 5d1, 6s2, and then it goes on, the 4f is successively filled. So at the end, lutetium 71 is having what configuration? 4f14, 5d1 and 6s2. And this is how, after this, what we get is, the next element we get is not the cerium, it is hafnium 72, which comes again in the D block. So these 14 elements which are starting from cerium to lutetium therefore they are placed separately. Now since their electrons are entering into the 4f, they are called 4f series elements. They are called 4f series elements. And since their starting elements is lanthanum, we call together all of these as lanthanoids. And we represent them by a common symbol Ln because all their physical and chemical properties are almost very similar. So we represent them by a common symbol called Ln. So this is what we have, the 4f lanthanoids. Then what happens is, in the very next period, that means in the 7th period, what we find is there is an element called actinium 89, which comes after radium, and we used to believe that it will be having a configuration of 5f1, 6d0 and 7s2, but rather than getting this configuration, what we get is 5f0, 6d1 and 7s2. So we are forced to place this element in the D block because its last electron is entering into the D subshell. But what we find is, in the very next 14 elements from thorium 90 to lawrencium 103, all elements are having their electrons entering into the 5f. Thorium is an exception in this case. Thorium's configuration is nothing is that it has no electron in the F, and it is 6d2 and 7s2. And in spite of having no electrons in the F, it is placed along with the other 5f series elements because its physical and chemical properties resembles with the rest of the actinoids, actinium, this 5f series elements. But in the very next element, protactinium 91, what we get is 5f, we get 2, 61 and 7s2, and this is how then 5f starts, and then it goes till lawrencium. So lawrencium 103 is having 5f14, 61 and 7s2, and then after this rutherfordium comes along after this actinium in the 4th group. So this is how, because we cannot separate the D block into two parts, and their actual position lies inside the D block transition elements, we are placing them separately, and this is how the second series, in which the 5f is successively filled, is separated out. That's why this is called 5f series, and the elements of this are called 5f series elements. And since the starting element is actinium, these all are called actinoids, and we don't have there any common symbol because their properties actually differ from each other to great extent, so we cannot represent them by a common symbol. So this is how the 4f and 5f gets separated from the main periodic table.